Okay, good example of FTC2 in action comes from 2013, number 4. So they give you this weird graph. It's a graph of f prime. They tell you some fairly important stuff in the problem. They show you where all the horizontal tangent lines are, which is exactly where they look like they are. Horizontal tangent lines at 1, 3, and 5. And then it tells you that f of 8 is 4, and it also gives you the area between the curve and the x-axis in a bunch of spots. So part A is fairly straightforward. Part A just asks where there's a local min for f. So A is looking for the min of the f function. So as far as a sign chart goes, you want to see, when you're looking for mins, you're looking for the derivative to change from negative to positive. Well, they gave you a graph of the derivative. So it looks like f prime is positive. Then f prime is 0 at 1. I'm also going to include 0 on my number line. And 8, might as well throw that out here. But f prime is positive because it's above the x-axis before 1. It stays positive until 4. Then it crosses over and it's negative until we hit 6. And then it's positive again from 6 to 8. So we are increasing, increasing, decreasing, increasing. This is your min at 6. There's a min at 6. Annoying part about the AP is this sign chart is not good enough. And also, if you're just looking at it from the graph, you can see when f prime is changing from positive to negative or negative to positive. So that is your sign chart. But they need you to say, since, or I would say something like, there is a min at x equals 6 because f prime changes from negative to positive. Done. That's part A. It's finished. Part B is a fairly similar thing, and it's asking you to find the min. Now, sneaky part about, I guess, this question is there is another potential min hiding in this problem. So we start at a place, and we start increasing. So wherever we started, we're instantly bigger. So this is also a contender to be a min. 0. So you need to remember to check the endpoints. Then we're increasing, increasing, then we start decreasing. This is a max. 4 is not under consideration. 6 is a min, and then we end increasing. So we end at sort of a potential max. We're looking for mins. So we really just need to figure out what the value is at 6 and what the value is at 0. So we need to do both of those things. So let's do it. You ultimately want to find the two things we need to find to do part B is we need to do f of 0, and then we also need to do f of 6. And whichever one's smaller is the absolute min, and then we're basically just done. So sneaky thing is we have a graph of the derivative there. They also tell you that this value of f of 8 is 4. So I'd like to find 0, and I know some stuff about 8. So what I would like to do is I would like to integrate from 8 to 0, this f prime function. Now the reason I want to do that is because the antiderivative of f prime is f. And then you're going to plug in 0 and you're going to plug in 8. So you're going to do f of 0 minus f of 8. And you're looking to find f of 0. The problem is when you do the antiderivative, you only want it to do this part. You don't want to have to do this other part, which is why we should start with f of 8 and add this thing, and then we should be okay. Because then these two guys are going to cancel out, and then we're okay. So the weird way to kind of think about it is the integral gives you the change in a quantity. This is where we're starting. We're finding the change to figure out where we ended up. This one's still a little weird because we're kind of going backwards, and we want 0, and we know 8, and 8's after 0. But if you kind of work out the mechanics of it algebraically, it might make a little bit better sense that way. But the integral, if you integrate the derivative, aka rate of change, it gives you the change in that quantity. So we can't do this because we don't know f of 0. So the way we have to do this is we have to use the information they tell us, which is that f of 8 is 4. You might find it easier to flip these limits and change it to a minus and go from 0 to 8 of f prime of x dx. And then that's where the areas under all these curves come into play. So let's find all those areas and then we should be okay. So starting from 0 and going to 8, we should get 4 minus 2 plus 6 minus 3 plus 7. Minus 3 because that guy's down. The area of a region can't really be negative, but we know that this is negative because it's down, and that's what the integral does for us. So 2 plus 6 is 8. 8 minus 3 is 5. 5 plus 7 is 12. This should turn into 4 minus 12, which is negative 8. If that's smaller than f of 6, then we've got a winner. And we want to do f of 6 basically the exact same way. We want to start with what we know, and we want to integrate from what we want, or what we know to what we want. So we know 8, we want to get to 6, and we're going to add 8 back, because the way this is going to work is we're going to do f of 6 minus f of 8. This f of 8 cancels, and then that leaves us with f of 6. I would probably, once again, just call this 4, switch the limits, go from 6 to 8, f prime of t dt. Let's find some area. So this should be 4 minus 7, which is negative 3. So this is the min, and we're done. F of 0 is the absolute min. And it happens to be negative 8. But in general, the way you're using this FTC as like a net change kind of thing is, the way I kind of think about it is, if you're looking for a value, f of the thing you want should be equal to f of the thing you have, or the thing you know, plus the integral from what you want to what you have of f prime of t dt. Or f prime of x dx, I guess. It doesn't really matter. Because what you're going to do is the antiderivative of f prime is f. You're going to do f of what you have plus f of what you want minus f of what you have, or what you know. These should cancel. That gives you the thing you want, and then you're done. So it might be easier to think of it like this. Personally, I think it might be easier if the lower limit is bigger than the upper limit to just switch those limits, but that's how we're kind of using the FTC to find a value. We have an anchor, and we're using the areas under the curve to see how much we grow. This one's a little strange because your anchor is the end, and you're almost going backwards, which is why we wound up reversing this limit and making this a minus sign. So C is pretty standard. B was kind of weird. C is pretty standard. C is when are you increasing and concave up? So if you're increasing and concave up, the derivative needs to be positive to be increasing. But for us to be concave up, the derivative needs to be, or sorry, increasing and concave down. So if you're increasing, f prime is positive. And if you're concave down, f prime is decreasing. If the derivative is decreasing, if something's derivative is negative, then that thing's going to be decreasing. But like ultimately, f double prime is going to be less than 0 when f prime is decreasing. So if this thing is decreasing, I know its derivative will be negative. Its derivative is the second derivative. So for us, the only places on the graph where the function is positive and decreasing, since this is a graph of the derivative, is from 0 to 1, and then also from 3 to 4. And I know this because f prime is positive and decreasing. Done. Quick and easy. But that's pretty much it. You're going to want to say that f prime is positive and decreasing and not say that f double prime is negative. The only reason you know that the derivative of that graph, aka the second derivative, is going to be negative is because you can see this graph decreasing. So they didn't give you a graph of f double prime, so they would kind of be thinking if you wrote f double prime as negative, they'd be like, why do you know that? Last little part is they give you some function, g of x, and g of x is going to be f of x cubed. And then they also tell you that f of 3 is negative 5 halves. And then they want you to eventually find g prime of 3. So we're going to take the derivative. So let's do the chain rule. 3 comes down, leave this alone, bump this down to squared, and then we go back inside for this guy's derivative. And then we just plug in 3. And whatever we get, we get. So g prime of 3 should be 3 times f of 3 squared times f prime of 3. F of 3, there's a reason they gave us this value, 3 times negative 5 halves squared times f prime of 3, and f prime of 3 is 4, because this graph is of f prime, and that should just be a 4. So this is 3 times 25 over 4 times 4. So basically these 4's cancel, and you should just get 75. And we're done. So hopefully that, at least part B of this, does a good job of FTC2, but we obviously hit a couple other issues like the chain rule. We did some sort of things about increasing and decreasing, and concavity, and all that good stuff. So hopefully this is a good example of that. So kind of sneaky, I think, on part B.